Yeah. Okay. What is this talk about? It's about AI development in 2025. What I mean with this is not building AI, but building with AI. So the idea of this talk is to give a few ideas. If you want to build software that uses AI to achieve features, what are current trends? What is stuff to watch out for? Quick intro. If you haven't met me, my name is Christoph Henkelmann. I studied computer science in Bonn. I'm a developer for 25 years now. Been doing AI for 15, the last 7 of those with my own AI company where we train models and build applications with AI. And we also help clients introduce AI. And obviously, I do talks, workshops, consulting a lot. We also do stuff in Java, which is a bit special. We will have a little Java part, Java and AI here. I hope you don't mind. Any Java people in the room? Well, that's quite a lot. Great. Yeah. Part of this talk will be how to build AI apps with Java. It's only short, but maybe it helps. So first, quickly, I will go over the intro a bit quicker than I thought that it was the loudspeaker, but it's the vacuum. Okay. What is AI? That's something you can. No, it isn't. Okay. That fixed it. You can discuss what, ask 3 experts and you get 4 opinions what AI is. The definition of AI that I like to use is from Artificial Intelligence, a Modern Approach, a great book about everything AI, not only deep learning and LLMs. And they have this matrix where they basically say, I'm sorry. Hope that's it now. Basically, they give 4 definitions in this matrix, which are derived from multiple sources, and they say definition number 1, it thinks like a human. I think we can agree if we get a piece of software that thinks exactly like a human, that's AI. Problem is we don't know how humans think. But often we don't want that. We want rational thought, which is often not the same, but something that thinks perfectly rational would, in my opinion, also be AI. And maybe you are not interested in how it thinks, you're interested in how it works, because we build product, we want a use out of this thing. And then you would want it to act like a human. I mean, acting perfectly like a human, that's definitely an AI system. And however, if you have a self-driving car, you don't want it to act like a human because, I mean, imagine Elon's cars will act like Elon. We don't want that. That would definitely be AI, but you definitely prefer the self-driving cars to act rationally. So yeah, sometimes for true AI, we want it to act rationally and not like a human. So choose your pick, and if you have these relatively wide definitions, you will see that actually AI has been here for decades, and there's a lot of different kinds of AI. So why are we now saying that now we finally got AI? Well, that happens every few years. When I was younger in the 90s, AI started to play chess better than any human. Everybody said, well, that's AI. Now we say, well, that's not. That's just a chess program. Well, the thing is, AI is a big field with many sub-techniques and subfields. And sorry, there's still the German AI. Well, this is AI, and a subfield of AI is machine learning. And there are many different, very interesting techniques for machine learning. But right now, what everybody's focusing on is deep learning, which is just one of many. And within deep learning, we are currently mainly focusing on transformers. And there are even different transformer types. There's not just GPT. There are other transformer architectures that are really useful. And then within GPT, there are actually alternatives. There's not just ChatGPT. So if I mean AI, I mean everything. But currently, for the first part of the talk, obviously, we have to look at LLMs. But as you noticed, we are very LLM heavy this year, but there's a lot of other cool stuff happening as well. And that's the second part of the talk, where we'll also look at things that are not LLMs, which is really important, I think. And a lot of cool stuff's happening there. But for the first part, let's look at GPT. I will not talk about all the cool new stuff that the big vendors put out, but because they have big marketing departments and we hear of all that anyway. So we will look at, well, OpenAI will not be mentioned a lot in this talk anymore, promise. except for mean jokes by me. So first, we need to repeat what an ML model is, but I think in this conference, not really that important. An ML model is actually the parameters that are the result of the machine learning. So a machine learning algorithm takes a generic algorithm and data, produces a parameterization of that algorithm for neural networks that would be the weights. And in practice, theoretically, the model is just the parameters. In practice, when you have a model file or something, you also have the structure of the network included. So for example, a GGUF file contains the weights of the model and the structure of the model. In layman's terms, it's everything you need to run the model. That's everything you need to run it. That's the model. Okay. Yeah, as I said, there's many kinds of AI, there's many kinds of transformers and many kinds of language models. And this is just a coarse overview over the language model space, GPT space. So these are all companies that produce GPT-like models. So if you need one, you are not forced to use OpenAI. AI doesn't equal OpenAI, and even GPT doesn't equal OpenAI. So this is a big overview of interesting companies, and there are many more that didn't fit the slides. And if you want to find out what's out there and how good they are, I recommend you have a look at LM Arena AI. We will have a closer look at that later. That's a website where you can test models side by side and rate them. And from those ratings, you get a ranking of what the users of the site think the best models are. And it's a very good way if you need a model for a task to, well, just check out the page and see what do we got here, right? That's a good way to keep track. Okay, when you see all those models and all those developments, especially just in the model space of LLMs, you can catch a case of FOMO, fear of missing out. So you think, oh my God, I didn't hear that there's a new, I don't know, Gemini something, and how could I miss that? To be frank, you don't need to make a constant comparison, okay, normally. Yeah, because there's a new model every week. When you build an application, that's the moment to research what's currently out there, and while you're building, maybe regularly update. It's not the end of the world if you are 6 months behind and you're using an LLM that's 6 months old. If it does the job, that's okay. What's more important is that you design your software in a flexible manner that you can switch LLMs. That's really, really important. Don't tie yourself to one vendor. Anthropic went down for some hours last week, and that was really problematic for a lot of people who couldn't switch. So there are ways to do this. In Python, I recommend AI Suite. It's a nice wrapper library. So basically, you can use all the major LLM vendors, and it's just one configuration change and you can switch to another LLM. In Java, there is Spring AI, which is finally mature. It's really good. I can recommend it. And if you just work with LLMs for yourself with a chatbot, I, for example, use anything LLM. It's not perfect, but it's okay. It allows me to have a chat on my desktop and switch between different models depending on the task. So if one goes down, I just switch to another vendor. I have API keys for the big ones, and I can still continue to have a chatbot at hand. So I want to look more at open source models, which I think are really, really important. The question is, when we talk about open source in the space of LLMs, the question is, what is open? So there's a lot that can be open, the training data or the research. That's what we start with. Next, there would be an ETL, extract, transform, load pipeline, and infrastructure code. That's super important. That's actually more important. Everybody knows these days how a transformer block works. They do have special tweaks at OpenAI or whatnot, probably, but I could build a GPT easily, and most people could do. There's not much magic in there. The magic is in the infrastructure code, in the ETL pipelining, and the training code and the hyperparameters. That's the next step. When you start training, you have the training code, you have the hyperparameters. And only once this is done, you have the inference code, is what you need to run it, and the weights to run it. So this is what we're actually working with most of the time. The rest we don't see. And typically, the open models are just open weight models. This is what's open source or open, and all this is generally hidden. So IBM Granite, you get this, but you don't get this. For the Google open source models, you get this. Sometimes maybe you get a paper. So only the last part typically is open. So many people say open weights instead of open source. So, and also open source doesn't mean, or open weights doesn't mean you can do anything with it. There are variants. So some you cannot use commercially, which for most of us probably is a no-go. Then others have a maximum on the number of users you can use. And what I really like is the don't do evil with it, which is the Google put in their license. They define you can't use it for malicious purposes. I really like to see how that holds up in court. And it's a bit fuzzy. So this is also hard from a legal standpoint. I think our legal departments in the companies we work with really like this one. And then there are a few ones that are Apache or MIT licensed. So I added a little feather of the Apache project. Almost no limitations. So where you have to be careful, they're often model derivatives. So there's an open weight model, and there's a new open weight model created with original weights. It's called a derivative model. Often done by a single very smart person who comes up with a great hack and makes the model a lot better, but they are not lawyers. So you have to check out. Sometimes they say, well, I want to give it to everybody, so I make this one Apache license, but the original one wasn't. So if you have a derivative model, check the parents and grandparents what licenses they have, because Meta might not agree with that if it's a llama-derived model and you manage to push it out to 3 billion people and you max the number of users, congratulations, but then there you will get a bill from Meta. Okay, let's look look at what I mean. I have three examples. OpenAI, nothing is open and you have to pay for this. So this is the most extreme case. Then you have Meta Llama, which is very popular. There's some stuff there is open. They publish their research, which is very nice. You have the hyperparameters, inference code weights, but they don't give you the ETL pipeline or the orchestration code for their clusters, right? And the only one that I could find, I must say the talk is a few weeks old. It's a stand-in, so my knowledge cutoff is the 1st of May. So yeah, this is the only one I could find back then that is truly open source is LNAI Olmo. It's roughly on the level of GPT 3.5, so it can't compare with current models. But I mean, that's not long ago. So 3 years later, we have a perfectly open source GPT 3.5. Yeah. So, and if we now look at this at the results of this chatbot arena, this is how it looks like. So, what they do calculate is an ELO score. Chess players will know that it's a score that's derived from. Well, if I manage to beat Kasparov, is he still alive? Well, if I manage to beat Kasparov, I will get a big boost because I'm a lousy chess player. If he beats me, he won't get a single point. So this is how ELO works. So they all compete and get bigger ELO scores. And I added the purely, so the white ones are the open models in some sense or other, and I put some famous closed ones in here for comparison. And you can see how well the open source models actually compare. And what is even more important, I added the size. So what is really interesting here, with Granite 3.1, you get a model that is better than GPT 3.5 Turbo and this is a logarithmic scale, at below 10 billion parameters. So this was GPT 3.5 Turbo, where everybody said, OpenAI has got this in the bag, they win the AI race. Well, if a product you paid billions to develop is available for free beta 1 year later, you haven't won the race, in my opinion. But hey, well, what am I to say? Time will tell. So you see a couple of points. First of all, I really like how you have really this almost straight lines that compares model count and performance. So yeah, bigger is better. But you also see how the initial commercial models, they sacrificed efficiency. They wanted to be out there first. So they are really big compared to their performance. And you see here with, you have Llama 4, which is already, depending on the version, beats GPT-4. And DeepSeek, of course, beats it by a lot. This, by the way, is what makes Gemini Flash so amazing. So people always go for this is the best model. Of course, the best is interesting. But frankly, I find this very impressive. They are below 10 billion parameters. And look, they are at 1,400 ELO. This is insanely good. This is insanely good. But you see, you get competitive models in the open source space. This is important. There are some European alternatives. I didn't put, of course, Mistral is here. It's also there. That's a European company, even if it's backed by US VCs. But there are some European open source alternatives as well. They didn't make it on the slide because they are not available for comparison in the chatbot arena. So they are still in their infancy, but they start to become competitive. They are really interesting. I picked two here. The interesting thing is the European open source models. They are built with grants by corporations between companies, and it's a different way to build models, and maybe that's the European way. We will see. Okay, they weren't on the slides, but we can look at one of them here as a comparison at the token one based on the benchmarks. I don't like the benchmarks so much because they are mostly saturated. The models have seen so much data that basically implicitly they have seen the benchmark data. So the benchmarks mostly are broken, and there's a lot of tuning and gaming and cheating in the benchmark game. So be careful with benchmarks. But I am not a Meta fan, but I like the Llama team, and they are working relatively fair, and those guys as well. So let's see. We see that this little 7B model, of course, Meta Llama is one of the reference open source models because it's really good, and we see it cannot beat Llama, but it comes. Oh, it does here. See, but it's not the best in any benchmark, but it's competitive with Llama, and it even comes close. So these models start to become an alternative, actually. So from this little X-course into the open source LLM space, which is, in my opinion, one of the most important trends in the LLM space, and it doesn't get enough attention, is what we will see. There's an insane market pressure. So LLMs, which were having an LLM would make you insanely rich and be the great investor case. I don't see it. LLMs are becoming a commodity, and there's a race to the bottom as far as pricing are concerned. Those big companies will struggle for a long time to get those billions back, no matter what Sam says. There is a withdrawal from American hyperscalers, both for political reasons and, yeah, that's a big part, but there is a tendency to look at open source models, host them yourselves, include them in your own software. People do not like anymore to simply attach to an API and stake all their company's fortunes on that, and neither should you. There's a trend toward open source software, federated learning, which I didn't mention here. It's still only in its infancy, but I think this will play a major part in the next few years in Europe, especially. Federated learning, that means that you share the learning between various nodes over the internet. So it's like SETI, if you remember SETI, Search for Extraterrestrial Intelligence, which was done by many little PCs and people remotely. I think this will happen in the LLM space as well, and it is already happening. And the money will be made, or is already starting to be made, with verticals and specialized models. So the money is not made with a big general purpose LLM because there are so many out there. There's a small profit margin. The money is made with a vertical. You really know a business and you go deep into one niche and you use. I will now show you a number of papers. I wanted to try out all of them, and I didn't manage to do a single one in my day-to-day business, so I just read the papers and looked at what they do, and I hope it's a good selection. What I think is interesting to know, to give you an idea of what is out there. Oh, added that. Added that slide twice. The first one, I find this very interesting, and when I made the slides, it was the only one, but in the last 4 or 6 weeks, there has been half a dozen of them. It's a tabular data foundation model. So you have to know that there are few bastions of classical data science and machine learning, and one of them is tabular data. Normally, you can solve regression problems or prediction problems that have tabular data, i.e. anything you can put in an Excel sheet. And there is stuff, you can do that with a neural network, but generally you end up with XGBoost or something else or other. So that's often what you still don't do with deep learning. And here is a very nice model. It's TAP-PFN. It's a foundation model for tabular data. So one of the things is, for tabular data, you have to train every model from scratch because the cases are so different. CNNs, LMMs, they are trained. They're often pre-trained on other data, and you fine-tune them to your case. You can't do that with tabular data, interestingly. Well, up until now. This is a model pre-trained on tabular data, so it's a model that is pre-trained in the space of tables, and now you can use your own table-shaped problem and fine-tune this model on it. And it has great performance that they claim beats other approaches. And one reason that they might actually be right is those of you who know what decision boundaries are. These are toy data sets of classification problems and different algorithms that try to find the decision boundaries around the classes. And you see the TAP-FN decision boundaries. These are synthetic data sets, but anyway, they are beautiful, clear decision boundaries and very varied. So if you have to work with tables, check this model out. In the last few weeks, I didn't have the time. I prepared 1 hour ago. There are 3 or 4 models that claim to beat this one. So look for tabular data foundation models. That's a new thing. Nobody looks at it. I mean, how much of your business data is in Excel, right? This is way more important than an OpenAI update, in my opinion, if you want to make money. Yeah. Then there's Sundial. There is time series, also time series. Everybody talks about LSTMs. Yeah, they're cool. Schmidt-Huber would agree. And but everybody says how you do time series with LSTMs, and sometimes it works. But frankly, I've talked to a lot of people who have done real-world time series projects, and it's always the same. You end up with windows, and within the windows, you do gradient boost, XGBoost, or something like that. Classical machine learning, bit similar to the tabular data. Well, not anymore. There's a foundation model now, which is transformer-based. So now we're back in transformers. This is wow, it's like a GPT for time series data, but don't quote me on that. So it's a transformer architecture that is pre-trained on time series data. So if you have your own time series data, you take a foundation model and check out. They claim it's better. Well, you tell me. That's one of the things when I present these things. Please free to connect on LinkedIn. If maybe in half a year say, well, we have this project and we actually tried Sundial. You're right, it works. That's really important information for me. I'd really like to get that feedback. Yeah, one of my favorite models, it's so great, Segment Anything, also by Meta. Segment Anything is amazing because it's a pre-trained model for image segmentation. Image segmentation means you segment parts of an image. So as a human, we know this from Sesame Street, you get a photo and you can circle all the objects, right? If I get an object here, I would automatically make a boundary around the table, maybe around the beamer. So we see what is a thing in an image. You can argue it's hierarchical. You could make a bounding box around me or around my jacket. This is a hierarchical thing. The cool thing about Segment Anything, it does that. You give it a photo and it segments all the parts of it. And you can control what it segments by giving it prompts. And here a prompt is a pixel, it's a click. This is a left click and a right click. So if we want the tongue of the dog, we say, left click here, please select the tongue, but not the dog, not the background, not the paw. And this thing does a pixel perfect segmentation without any of your own data. And this was what Segment Anything 1 already did, but 2 can track it in videos. So, so this is so amazing for any tracking tasks you have. So you can start on the first frame with an object. You take some YOLO or something. You take a detector, and then you take Segment Anything, and you can track your object over various video frames. And the cool thing, and this is what I really like, you see here, it loses track of the tongue, and now you just have to add the click on the tongue. You don't have to click the other one, so it's easy to recover in a later frame when the object you are tracking moves out of sight. This is one I found last week. I had to add this one. I had to add because that blew my mind. It's called All Tracker. It is also this is that one also. Oh, sorry, that one also segments, but you can use it. It can track. But this is really cool. This tracks pixels. So it starts with an initial image, and it tracks the trajectory of all pixels through a video. And the worst part is, it's amazing. Here's the monkey. The monkey looks out of the picture, so the face is hidden from camera, and it looks back, and it finds the pixels again. So it tracks, and it does that for all pixels in the video. So it does it at high resolution for every pixel. And here comes the kicker. 16 megabytes model. Works at 60 frames in real time. That's what they claim. I didn't try it. So tell me if they were right. I really need to try this. And it's also important you can detect optical flow. So you can detect where in an image there's a change. Like you can build so cool stuff with it. And I think it's even open source. I hope. Check the license before. What I got, it's open source. And 16 megabytes, that's brutal. That's brutal. Then there's one I really liked. It's obscure NN unit because all these segmentation tasks, they're great. We have to look at the time. Um, there's some stuff you cannot do with segment anything. It wouldn't work on ultrasound images or X-rays. It needs photos. So these images are way too specialized and obscure for proper segmentation. So you still sometimes have to train your own UNet. If you know, UNet is an architecture you would use for this kind of stuff. But getting the UNet training right is devilishly hard. So this is a really annoying part. But there's something called NN unit, which isn't a new model, but a model that looks at your task and then configures the UNet so it converges. So this is nice. If you have to do something like this, medical material science or something, I'd check this out. They claim it's good. I'm definitely gonna try it on my next material sciences project. Embedding models, RAG, you know, I think we all know what you need them for. Yesterday at my embeddings talk. If you want a good embedding for text, check out Nomic Embed Text V2. And there's a lot of open source embedding models that are really, really good. So there's a large variety. They are free. They are small. Look at it. It's 300, roughly 300 million, not billion, active parameters. So it's really, really fast. You can run it probably even without a GPU. And it's got great results. And if you don't like this one, there's at least a dozen other open source ones. Then, of course, Flux.1 Schnell by Black Forest Labs. So this is image generation, open source, really fast, really good. They have commercial closed source models as well. But this one is open source and it's really small. You can run it on a gaming GPU. Great thing. And for once, a German company, which is rare these days. And because we're in Germany, this was actually intended for a German conference. So we have a problem in Germany with speech-to-text and text-to-speech open source models. If you do English, you don't need any of the commercial vendors. There's great SST and TTS models, but in German it's hard, especially the speaking part. And up until now, you needed the commercial vendors, but a guy called Sebastian Boccia made this model. He doesn't even have a homepage for it. He posted it on his LinkedIn, for God's sakes. He made this model called Kartoffel, and it's based off Orpheus 3B, which and it's really good in speaking German. So if you need your computer to speak good German, and he also has the emotions and little laughs. You don't need it that much in German, but sometimes you do. Yeah, I think it even can do accents or something. So it's pretty good. It's pretty good. So and it's small, 3 billion parameters. So great thing. Okay. Yeah, where do you get that stuff? Who here? Let's do it the other way around. It's so embarrassing. Who of you doesn't know something? Please raise your hands. Who of you knows of Hugging Face? Okay, that's some people say it. So all this stuff is on Hugging Face. Frankly, I haven't seen any open source model that you can actually use for something useful that's not on Hugging Face. If you're not on Hugging Face, you're not out there. That's the thing. It's the GitHub for models. So if you want that stuff, you will all find it on Hugging Face. Hugging Face is so big now, sometimes it's hard to search. I actually use a deep research to find models in certain spaces on Hugging Face because the Hugging Face search isn't that good. So I always use deep research to find my Hugging Face models if I have to go into a new space these days. So I say it well, these are the licenses I want, these are the constraints, and it's pretty good at finding them. I hate newsletters. There are so many bad ones out there, but I have to say, I really have to recommend Alpha Signal. If you're not subscribed yet, I don't get paid. They have advertisement, they make money with it. I normally don't endorse any stuff, but really you should subscribe to Alpha Signal. That helps you keep track of that stuff. They're really good. Another one with a much lower frequency, but also good by Andrew New is The Batch. It's also a really good newsletter. So if you want to keep track, do that. And frankly, you can, since Twitter X has become a toxic wasteland, you can actually find good stuff on LinkedIn if you follow the right people. So lots of these paper recommendations I found on LinkedIn just by following people from Hugging Face. You can just start by following MLcon, and if he shares something good from another person, then you follow that person, and after a few weeks, you actually have a nice feed with AI news. And if we just had a good solution to filter all the toxic, annoying stuff from my LinkedIn feed, then I would have a good AI feed. So, how do you run it? Actually, there are many ways to run it, and you can actually. I have still 11. We can actually, much of the smaller ones, this is why they're really tiny, you can run on-prem. You can have your app and it uses the model and a CPU. You can have an app and it uses a model and GPU. On-prem GPU hardware is a bit harder to maintain, but that works. Or you virtualize the model into a container, Docker container, whatever, Kubernetes pod, and you have your app communicate with it. Why even do these? Because these days we all just virtualize something. It's all blah, 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 Dockers and Kubernetes clusters. Well, sometimes you need really low latency. So I've built stuff where we needed to look at video frames, and you can't put your model that analyzes the video on another machine. Even if it's a virtual machine on the same hardware, you still have the network communication, and you get too much latency, you get too much data traffic, because the video will be compressed, right? And you have to decompress every frame. You know how big frames get when you have raw data. You could re-encode them as JPEG, but that's stupid. That's what the video codec is for. So yeah, I built that system, and it works at least at 10 to 20 frames per second. They now want to decentralize everything and do the processing on different nodes. I'm really looking forward to that, how that will go. Not good. Then what you can do is you, of course, can use any kind of remote system. You have your machine and you have to work via APIs. So you host your models on a different machine or even in a data center. For example, you can have an app, you host your model in a data center and connect via the internet, i.e. this little cloud symbol. And of course, if you do that with any closed source model, this is what you get. This is how your architecture will look. You know, you send it to the internet and that's all. I don't want to go into too much detail, but I just wanted to remind you, because everybody, you know, this seems to be the standard. Everybody just thinks that the model has to be on its separate machine or behind an API. That's not true. You can actually include the models. You can build a Rust application that's native on your desktop, and you take your model and you trace it with Onyx, which is a runtime for models, and you include the Rust Onyx runtime, which is tiny, and you have a tiny, nice little native app with a really powerful model. And it runs on a desktop without any internet connectivity. This still works, and it's great. It actually should be done more often. Okay, what trends can we deduce from this? Specialized models continue to be relevant. You can't solve every task with a multimodal LLM. These models are way better at what they do than any LLM will be for a long time. Open source is strong in that space. I didn't show any commercial models because I wanted to put the focus on open source because I'm a Linux nerd. But frankly, there are not many interesting specialized closed source models. That's the interesting thing. I only found 1 or 2 models where you actually have to pay to get access to the model. And that's it. Nothing worth mentioning, to be honest. So open source is strong in this space, and this will not change soon. But virtualization will be ever more important. I really translated this in the last moment, sorry. It will be more important, so I'm a fan of integrating the model in the application, but very often, you know, you have 3 models, one with PyTorch, one with Keras, one with PaddlePaddle, the first one on Python 3.7, the other one on 3.11, and it seems that the Python model, the Python people have solved this problem by just, it works on my local machine, so let's ship your local machine. So virtualization becomes more important. Distributed systems get more distributed. There is no way past Hugging Face. Monetization with very special closed source models is possible. So if you sit on a treasure trove of data that no one else has and you have the know-how and you can make a model that is really, really important in one special space, you can have a great product, but that's rare. But if you have it, it can be successful, but it's really hard. So there is still that. Okay, Java integration. How much time do we have left? Time's up. Okay, you want to build a Java AI app. What you do? The first thing is you really want the model in your Java process. Then I recommend DJL, Deep Java Learning, to which I committed also some stuff. Some layers in there are mine. You can do either PyTorch tracing, works very well. There are various ways you can do it, but the ones I recommend is either you use a PyTorch model and trace it and run it in DJL, or you make an Onyx model and trace it. I would go the Onyx route first. When I started doing this, we did this for multiple clients actually, and once you know how to do it, it's actually relatively easy. When I started, PyTorch tracing was the only thing that was performant and stable, but it was stable. We didn't have any errors, so this works really well. Onyx was still in its infancy. Now I've heard from other people that do this, do Onyx first. Onyx is smaller, it's more portable than afterwards. So if you want to give this a spin, try to get your transform your model into Onyx and run it in the Java server or application. When you don't want this included in your code, obviously you just come up with a little REST server. And in Python, that's super easy to do. We always use FastRP, but there's probably 24 other frameworks you can use. FastRP, it's 4 lines of code. You load the model, you do the inference, you send it back via JSON or an image or whatever. So for a good Java developer, this is really easy to do in one afternoon. Yeah, because Python is just, it's a toy scripting language for doing funny stuff. So don't worry if you're not a Python developer. It's really easy to write a REST server in Python, and then you can use arbitrary language models from your Java servers. If you want to use Gen AI and LLMs, I recommend you use Spring AI. It's a great framework. It's like it's a bit like LangChain, but good. And either you use a commercial API or you use Ollama to run your open source model. So this is for the open source language models. I really recommend Ollama. There's also, I think, VLLM. Many pros that host, on big clusters, they all use VLLM. I don't know why, but they probably have a reason. So check that out. You can start with Ollama. It's super easy. You really say it's a process, Ollama, model file, boom, and you have a REST server for your model. It's out of the box, works really great. And then you just use Spring AI and talk to your own LLM server, and you can build great LLM application. It's okay. Yeah, as I said, DJL is a wrapper. The thing is, DJL is a wrapper for deep learning engines. It's like Log4j is a wrapper for various loggers, and JDBC is a wrapper for various database frameworks. DJL is a wrapper for various deep learning engines. The cool thing about it is what you also get, you get NumPy in Java. So it has a complete implementation of the NumPy interface, and what you get is NumPy on Java, either CPU accelerated with native code, like the Python people do it, or GPU accelerated, which is really cool. So even if you don't do deep learning or anything else, if you have an arbitrary and numerically heavy algorithm that you need to run in a Java server, you can use this and you get really, really fast code. So if you just want to do some calculations really quick, that's also useful for that. And it has another nice stuff. So why is this good? It reduces latency and also deployment complexity, because in the end, you just get one big jar file which contains everything, and you can deploy it as you are used to. The problem is you also need the GPU drivers and the CUDA stuff, etc. So it makes integration and programming a bit more complex. So this is more complex than just using a Python REST server and connecting to it. So if that works, frankly, do that. It's quicker and easier. But if you need the low latency and the integration with your code, it's a bit more complex to program, but it works. But what it does is decreases infrastructure complexity, because you don't need a different type of node in your infrastructure. Spring AI is about integration, so you don't do models with Spring AI. It can't run any models. That's not what it's for. It's for accessing APIs. So, but it's great because it's everything built in. An MCP server, the Java guy, Java people know it. I mean, it's really easy to build a REST call in Java. You just make a method and say it's a REST call. Same with MCP. I built an MCP server, i.e. I built a method that does something and I said add MCP, and you have an MCP server in Spring AI. I think it's 1 or 2 lines more of setup, but it's ridiculously simple. It also has already stuff out of the box for RAG, and it's mostly provider agnostic, so you can switch the models. And it even already has support embeddings and some TTS and STT support, but speech to text, text to speech, but that's still wobbly. That's still in infancy. So there's no need, if you have an application in an existing enterprise application and you want to use LLMs with it, no need to fire up Python if you don't want to run your own models anymore. Okay, trends. Training in Java is not relevant. I trained my own transformer 6 years ago in my own Kotlin RP on the JVM. Those were the good times. Regrettably, this didn't catch on. So training in Java, regrettably. You can do it. It's fun. You can do it even with DJL. You have the complete PyTorch API, so you can build your model in Java and train it. But regrettably, even I wouldn't recommend that. But it's fun. But as an integration platform now, it will really catch up. Enterprise is slow to move, and everybody now has FOMO. We need to get LLMs into our applications. And this will be big, I guarantee you. If you do not train yourself, like you need only superficial Python skills. If you don't want to train your own models now and just want to use LLMs, no need to learn Python anymore. For model integration, you need to virtualize a lot. So agents. This talk was a bit longer than the time slot provides for. So what I do now is I have a bit on agents, and then I have a bit on, will we all be wiped out by the singularity? So I will extend this by 5 or 7 minutes, but I don't mind at all. If you need to go to the toilet or grab a coffee, just walk out. I will not take offense. Agents. Agents, the big new thing. So we have rediscovered for loops. Seriously, what are agents though? If you really want to look into the whole topic of agents, I can recommend those 2 books, especially the left one. That's my favorite, The Society of Mind. Because guess what? Agents are around for 45 years now. Agents were the thing in classic AI. So it's all about agent architectures if you go back 30, 40 years. So people are literally reinventing the wheel right now. And the agent definition of an agent was much more complex and nuanced back then. So if you want inspiration on agents, look at these books, especially the left one. It's for free, legally available for free online. I recommend. The thing is with the Society of Mind is it's a unique book. You will get so much inspiration out of it. It's great. Back then, for example, the belief, desire, intention software model, that was a software model to build what we now call agentic software. There's a whole design pattern that people studied. So if you want to dig into it, also consider the classics. Then again, very quickly, how to build agents. If you are a programmer, if you're a real programmer, I would recommend you don't start with an agent framework, because just Google a bit. It's really simple. It's literally just you have a planner that decides, oh, what steps do I need to take? Then you have a loop that does the steps and checks, did it work? Did it work? Okay, try again. You have a counter that says, well, if it didn't work for 10 steps, return, sorry, couldn't do that day. Sorry, Dave, I can't do that. So this is agentic programming. So those frameworks often hinder you more than they help you. That's not a joke, because it provides unnecessary abstraction. An agentic framework is a couple of REST calls, a loop, and the thing is, your case will be so specific anyway that you need to change a lot. So I would actually recommend you try just yourself with some programming. If you are not so much into programming, you can use low-code and no-code tools. N8N is very popular. We had a presentation of Zybo here, and there's also circuits. So a lot of these tools are out there. So they can actually help. So let's be fair, not all of these tools are useless, but maybe just to get an idea, you just need to start with an LLM call. Okay, then really important for this whole thing is the model context protocol. That is here to stay. But it's not as complicated as people make out. It's basically a way to make your resources available as tools to LLMs. So, and it doesn't need to be like a tool can be anything. It can be a database lookup. It can be the current time. It can be a call to another LLM model. It can be data access. For example, my next task, which I really want to do, is make a local MCP so I can modify my open office spreadsheets. So I make the spreadsheets available to the model. So you can use it for all kinds of stuff. So if your model needs to do something, you want to give it access, make an MCP. So yeah, I made a lot of fun. It's just a for loop, but there will be a massive gain in agentic workflows. These things work, they are cool, but don't get too intimidated by them. Nobody knows exactly how that is going to look. So if you say you need to know these, you know, the LinkedIn post with 8 blinking pictures, these are the agent architectures you need to know. No, that's total bullshit. Yeah, you can look at them, get some inspiration. It's nice. Yeah, just Google them. You don't need to know them because in 3 months there will be a new one that works better. So we don't know which agentic pattern will really work. This is now in a lot of flux, and this will settle. And in 3 years, there will be established method, and there will be a talk here at the conference. This is best practices and agents, but anybody who says now that this is the thing, they are lying. You can't know that right now. So beware the hype and the snake boil. So this is the natural evolution of bros. They started out as bros, then they became crypto bros, then they became GPT pros, then they shortly were prompt bros, and now they're becoming agent bros. Let's see where it ends up. Okay, and this is the last thing. So is all this AI thing empty hype, or are we facing the apocalypse? There are 2 very interesting articles or web pages that came along lately. The one is AI 2027. We predict that the impact of superhuman AI over the next decade will be enormous, exceeding that of the Industrial Revolution. And they tell you exactly in which year who will lose their jobs, very precise. And then there's Less Wrong, and they have this. It's a great post that went very rival, and we tested the new models. The gains are minute. It's all bullshit. So who's right? Are we at the end of the scaling or not? Well, there's something called scaling laws. So people looked at what happens if we make neural networks bigger. That's called a scaling law. Each neural network, LLM, has, depending on the architecture, slightly different scaling laws. So sometimes the question is, do I invest my money into larger models or longer training? Because I can do both. Do I do more data or bigger models? And they analyze the scaling laws, and basically more is more in all domains. But one thing is really important. You see that this is a logarithmic scale. So everybody who tells you that the gain in AI and LLMs is exponential, yes, the cost is exponential, but the growth is linear. It's literally the opposite of exponential growth. If I need exponential resources to get linear gains, that's not exponential growth. It's literally the difference, the opposite. So yeah. And we are starting to push the boundaries. They're starting to feel it. Sam needs another 5 billion for the next generation of AI. Ever more billions, ever more compute for linear gains. So there is a limit to that. You can't continue this indefinitely. So this is an argument against that we are pretty much at the end of the evolution of these LLMs right now. One thing that I find super interesting are the ARC AGI challenges. That's a benchmark that's not saturated yet. And the idea is to have tasks that are really, really hard for current AI. One of these is this. It's pretty easy for a human if you stare at it for 1 or 2 minutes. Normally, I want to make a show of it. We all look at it and figure it out together. But, well, the thing is pretty easy, right? Yellow if it has no holes, green if it has one, etc., etc. And we see this is the example. So this gets green, yellow, etc., etc. And if a number of holes isn't present, we don't show it. So this little structure here is removed from the output. So this is a very simple puzzle. You can have an intelligence test. LLMs fail miserably if this, no matter how many reasoning tokens you throw at them. So this is the ARC challenge. It's full of these funny little things. And the current, like 1 month ago, the best models could do 4%. A human can easily do above 90. two humans together saturate this. So any two average intelligence humans always beat it at 100%. So it's not hard for us. It's hard for them in this case. So there's also zero bench, which I think is a bit unfair. I can solve a single one of these tasks. I tried. I mean, they are ridiculously hard. The image shows calligraphic writing in Farsi with some letters annotated with arrows. If we put these letters together, what would the message be when translated into English? Use the colors in the following order: red, orange. Anybody here speak Farsi? I always try this. Nobody speaks Farsi? Ah, damn it. I really want to know what the solution to this is. This one I should be able to do, answer the question that is written in the shape of a star among the mass of letters. I literally stared at this for 10 minutes. I can't see the star. Anybody see what the question is in the shape of a star? Okay, so yeah, that's zero bench, aptly named, because when they started, the pass rate was literally zero. Now it's 1. You get the slides later. If any of you manages to find this out, please drop me a note. So what will happen next? A, scaling laws will end growth. Or B, new algorithmic progress will allow further scaling. I mean, if we find something that makes them an order of magnitude more efficient, see, flash attention was such a thing. With flash attention, they could scale by a factor of 10. Boom, models got bigger and better. Or is this the end? We need to build really nice agents and do good software engineering to get the most out of what we have. The question you should ask is, cui bono? The AI 2027 people definitely had a stake, financial stake into some of the companies. So you always have to look out who says what. So yeah, make up your own mind and keep a lookout on the benchmarks. Use open source. Sorry for stretching the time so much, but I hope you liked it. Thank you very much.